You know, when you look at any amazing piece of tech, a phone, a car, even a jet engine, at its core, it all starts with turning a boring old block of raw material into a super precise part. Today, we're going to break down two of the most fundamental processes that make that magic happen: face milling and peripheral milling.
So let's start with the big question, right? You've got this chunk of metal, say aluminum or steel. How in the world do you go from that raw block to a finished functional component? Well, the short answer is a process called milling, but it's how you do it that really matters.
Because look, anyone can just grind away metal. The real trick, the whole point of modern manufacturing, is finding that perfect sweet spot. You've got to remove material fast enough to be efficient to actually make money, but you also have to be unbelievably accurate. That balancing act, that's the entire game.
All right, so where do we even begin this journey? Well, just like building a house, you have to start with a perfect foundation. And in the world of machining, step one is always about getting that first surface absolutely perfect. It's totally non-negotiable.
And that first critical step is called face milling. The name kind of gives it away, right? You're literally machining the face, or the top surface, of your part. You have this big rotating cutter that just sweeps across the top, and the little inserts on the end of that tool shear away the material, leaving behind this beautiful, flat, smooth plane.
So why is this so important? I mean, it's not just about making it look pretty. Face milling is what establishes your Z0 datum. Just think of that as ground zero, the absolute starting point. Every single other measurement you make on that part, every hole you drill, every pocket you cut, is going to be measured from this one perfect surface. If you mess this up, the entire part is junk. It is quite literally the foundation of everything that follows.
Okay, so our foundation is poured, it's perfectly flat, and our Z0 is locked in. Now comes the fun part. Now we can actually start sculpting the details. It's time to shape the outside of the part and all its features. And for that, we turn to step 2, peripheral milling.
So here we have face milling's partner in crime, peripheral milling. And the key thing to notice here is the huge difference in where the cutting is happening. We're not using the end of the tool anymore. Now we're cutting with the sides of the tool. You know, those sharp helical flutes. This is how we carve around the part's periphery or its edges and dig out all those internal features.
And man, this is where you really see how versatile peripheral milling is. This is the workhorse. It's what carves the final profile of the part. It creates all the internal pockets and slots, and here's a big one. It can machine a perfect 90-degree square shoulder. Most face mills just can't do that. And if you get into specialized tools, this is even how you create those crazy complex 3D surfaces.
All right, so we've met our two main players, face milling and peripheral milling. Now, to really get this locked in our heads, let's put them side by side, a little head-to-head comparison.
If you remember only one thing from this whole explainer, make it this. It all boils down to the tool's orientation. With face milling, the spindle, the part of the machine that spins, is perpendicular, or at a 90-degree angle to the surface you're cutting. But with peripheral milling, that same spindle is now parallel to the surface. That one geometric shift, it changes absolutely everything about the operation. And this chart just lays it all out, nice and clean. What tool are you using? A big face mill or a smaller end mill? What's the main goal? A flat foundation versus shaping details. Where does the cutting happen? The end of the tool versus the sides. And the spindle, perpendicular versus parallel. See, they're not competitors. They're two different tools for two different but equally important jobs.
Okay, so knowing the what is one thing, but this is next-gen manufacturing, right? So we have to talk about how to do it really, really well. So let's get into what it takes to unlock peak performance.
This quote, wow, this gets right to the point. What it's basically saying is that to get that perfect blend of speed and accuracy, you can't be shy. The cutting tools we have today are incredible pieces of engineering. They are designed to be pushed hard, and the people who make them give you all the data you need to do it. Sometimes running a tool too slow is just as bad for it as running it too fast.
But, and this is a huge but, before you can even think about pushing those limits, you have to defeat the #1 villain of high-performance milling, and that enemy has a name: Runout. Or, to put it simply, Wobble. It just means the tool isn't spinning perfectly true on its center axis.
And that little wobble sets off this absolutely destructive chain reaction. It's like dominoes falling. That tiny bit of misalignment means only one side of the tool is really doing the cutting. That leads to vibration and a horrible surface finish. And it will absolutely smoke your expensive cutting tools, sometimes in a matter of seconds. It's a total performance killer.
So how do you fight back? The answer is all about how you hold the tool.
The old-school side lock holders, yeah, they're just famous for causing runout. The modern solution is so much better. Things like hydraulic chucks or shrink fit holders, they grip the tool with this incredible uniform pressure all the way around. It's like a perfect 360-degree handshake that virtually eliminates any wobble and gives you a super rigid, balanced setup.
So let's wrap this all up. When you look at the future of advanced manufacturing, it becomes really clear that precision isn't just one part of the equation. No, precision is the entire equation.
And this right here, this is the recipe for success. It's a three-legged stool. You need the right parameters, your speeds and feeds. You need the right tool holding to kill that runout. And you need the right strategy, knowing exactly when to use face milling for your foundation and when to switch to peripheral milling to shape the details.
And here's the big takeaway. These two processes might sound like basic 101 level stuff, but they're the absolute bedrock of everything. You can't build a stable skyscraper on a shaky foundation, and you sure can't do complex, high-speed 5-axis machining if you haven't totally mastered these fundamentals.
So once you understand how to create that perfect first surface and then how to shape a part with incredible precision, well, that just opens up a whole universe of possibilities. It really is the core skill set for everything cool being built today and tomorrow. So the only question left is, what are we going to build with it?